Okay, so now today we need to discuss about the topic name is SD-WAN concept. Good, Simran, can you hear me? Yes. If you have
Yes,
any query,
yes,
so you can send me on Zoom chat message. Okay,
sure,
Zoom chat is available. You can send hi message, then we can okay discuss if you have any doubts. Okay, any other doubts, so you can send me on Zoom chat message. So right now today we need
sure.
to start. The topic name is SD-WAN. Before starting SD-WAN, must be clear the concept, uh, network concept. Why we use SD-WAN and which scenario we use SD-WAN, how to implement, how many types SD-WAN solution available right now, and which vendor will provide the SD-WAN solutions. Clear? And which type of protocol support, how to configure, how to deploy, how to troubleshoot. Clear? So we can discuss each and every points one by one. But before doing SD-WAN scenario, must be clear a traditional routing. Traditional routing means if you have any query about the traditional routing, so clear this one. So if we discuss a traditional routing, so in traditional routing, we are using some concept. If you are having a traditional routing LAN environment, a WAN environment, clear, or if you're having a CAN environment, a campus area network, if you're having a private area network, so how to implement traditional routing? In traditional routing we are using some routing concept, we are using some a switching concept, we are using some a security concepts, some quality of service we deploy, clear, and some a load balancer. LB means a load balancer we deploy. Now in traditional routing we are using a multiple types of devices. In traditional routing, devices, how many types devices we are using? So we are using router. Okay, router we are getting a two types. One is my enterprise router, one is my data center router, one is my service provider router. Okay, all types of router available in traditional routing, depends on your design. Now a second device we are getting a switch. This switch we are getting three types. One is my layer 2, layer 3. This layer 3 switch also known as a multi-layer switch. Okay, third type of switch we are calling again. This one is my data center switch, service provider switch, or enterprise network switch. Okay, if someone asking, sir, a difference in between layer 2, layer 3, or this one switch, what is the difference? Basically in layer 2, in layer 3 we are getting a fast ethernet port, we are getting a gig ports, these two ports available, but sometimes we are also getting SFP ports. SFP ports we are connecting which one, a fiber cables with SFP modules. This modules we connect on layer 2 switch, on layer 3 switch. And one more point available, PoE supported. But in data center, service provider, enterprise, if we are using switch, so we are getting a gig ports with a speed a 10 GB, 20 GB, 40 GB up to. And we are also getting SFP ports, not a limited. In layer 2, in layer 3, we are getting a limited. But in this case, we are getting 4, 6, 8, and we are getting some cases 16 also. One more thing, this switch is PoE supported. PoE means power over Ethernet. If you want to provide your power for access point, IP phones, so this PoE concept will provide. Now, router switch is clear. Now, next device. Next device in traditional routing, we are using some of firewalls. This firewalls multi-vendor, Palo Alto, Fortinet, ASA, and multiple checkpoints we are using also. Now, this firewall we are using to do a filter, uh, packet inspection, clear, or malware analysis. If you want to check a signature, So you can use. Now, one more device available. It's called a load balancer. Why we use load balancer? A distribute a data traffic. Okay, now basically in traditional routing, this devices depends on a network, users, clear, or devices. Which devices? End devices. If you are having a number of user, number of end devices more than 1000, then we need to use advanced devices. A router processing must be high, switch processing must be high, storage also we are need to extra. Clear? Now, in traditional routing, we implement routing concept. In routing, we discuss static routing we use, default routing we use, some EIGRP, OSPF, this protocols we use. Clear? Now, in routing, we are using ACL, we are using a route map, we are using a prefix list, we are using some policy based routing as well. We are using a net concept. Clear? We are using DSCP concept in routing. Now, if you discuss about switching, in switching we discuss VLAN. Okay, access port. AP means access port. TP, trunk port. We are using inter VLAN routing to communicate different VLANs. STP, RSTP, Ether channel. Clear? Some scenarios we are using VTP. Okay, in security, we implement port security. We implement DSCP snooping, IP source guard we are using, ARP inspection. ARP inspection we are using to inspect my ARP and multiple features. Okay, quality of service for a prioritization concept we are using. Load balancer, same purpose, distribute your data traffic. So in traditional routing, if we design, for example, this one is your small setup in traditional routing. This one is your router 1. This one is your router 2. Clear? And both router connected with, this one is ISP1, this one is ISP2. This kind of design we are getting. Now, those routers are connected with some firewall 1, firewall 2. And this firewall we are getting HA concept. Clear? Now, we are using after firewall a distribution layer switches. This side we are also using. Now, after distribution layer switches, we are connecting some access layer switch this side, access layer switch this side, access layer switch this side, this side. Now, this switch connected with this side, this one, and this one. And both distribution switch connected with a redundant links also. Now, this access switch connected with some of LAN user. This one also connected with some of LAN users. And this access layer switch connected with a physical server. This one is also physical server. But this side we are connecting a VM server. This side we are connecting some VM server. Basically, this server will provide, for example, FTP service. This one for my website. This VM will deploy with a multiple servers, multiple application server, database server. This VM will install a specific server. For example, this server for SIP purpose. Clear? Now, what will be happen now? Next, if in this design, we implement a traditional routing scenario. So in this design, if we are using a traditional routing scenario, so how to implement configuration? So step by step we follow, because before doing software defined network solution must be clear traditional. In traditional routing, first point, you just need to go to a routers. Basically, this router will perform a routing task or packet forwarding. Clear? Or this router also select a path. Now, basically this firewall will do a packet filtering, deep packet inspection, or signature verify, websites you can block, unblock. Now, this distribution switch provide a connectivities plus VLAN concept plus a trunk concept plus a bundling for ether channel, plus this distribution switch also performing a some routing case. Now, this access layer switches only provide a connectivities for which devices? End devices. And VLAN mapping only we done. VLAN map. And data forwarding, data receive on the basis of only layer 2. So for example, this one is your HQ, or you can say head office. This one is your HQ site, and you just need to connect a multiple sites. So I'm saying for this one side, we are getting a branch number 1, and this one is my a Delhi location. In this branch, we are getting a router. This router connected with a switch, and switch connected with end users, some biometric devices for attendance, some other equipments, IP phones also available. Now, how to connect this branch in traditional routing? In traditional routing, this branch connected with ISP, and ISP will provide a connectivity, some MPLS connection, some lease line connection, some broadband connection you can also use. So this one is connectivity. Sometimes we are getting a point-to-point connectivities. So basically, whenever this branch connected with my HQ, so this router must be configured first a routing, then path decision we need to set, then we need to define some firewall routes, some tunnel configuration we also done, some VRF concept, some IPsec concept to secure your connections, clear, secure your data traffic in between HQ to branches. This switch also perform a switching task, but must be manually configured every branch. So in traditional routing, if you have 10 sites, or if you have 20 sites, 50 sites, you need to deploy. You need to connect with HQ. So how to connect in traditional routing? One by one, every branch we need to configure. So basically in traditional routing, we are getting a lots of issues, but a common issue, manual configuration, and each device separately processing each and every instance for routing, for switching, for security, for data forwarding, for packet filtering, for deep packet inspection. In traditional routing, we are also getting some issues. For example, if this HQ headquarters are connected with 10 sites, so this router must be having high-end CPUs, 2-core CPU, 4-core CPU, must be having storages maximum required 2 GB, 4 GB, 6 GB. Clear? Okay. This firewall, whenever this firewall receive or send any data traffic, for example, number of 1,000 users traffic we are receiving on firewall 1 or firewall 2. So in this case, this firewalls separately run instance for each packets, each data. So again, this links must be having up to 10 GB. Again, this distribution switch, whenever receive 1,000 users traffic, 100 users traffic, so this distribution switch also getting CPU utilization is high, storage issues, bandwidth issues, clear? So in traditional routing, if you are using a routers, if you are using a router, if you are using a switch, if you are using a firewall, if you are using a load balancers, so those devices having some planes, those devices having some planes. Which type planes available? These planes will define how to work or how to handle data, how to process, and one more thing, how to forward, receive, and how to verify a packet types. Packet types. Basically, we are getting a two types packet, a routed packet and routing packet. Clear? Some other types of packet also available. So this plane will be defined. Basically, each device will maintain separately. For example, if we discuss planes, so we are getting first plane is a control plane. Then second plane name is a data plane. This plane also known as a forwarding plane. Third plane name is management plane. Fourth plane also available. It's called a service plane. Clear? Now, in traditional routing, each device have a separately planes. Now, what will be happen in control plane? Basically, control plane, this plane handle a routing related packets. Clear? Or you can say all types of updates handle. So inside updates, if you're having any query, inside updates, sometimes we carry protocol information, sometimes we carry network information, sometimes we are carrying path attributes, sometimes we are carrying some metric informations. Clear? So this updates will handle by a control plane. Now, so router have separate control plane, switch have separate, firewall separate, load balancer is separate. Now one more thing, data plane. Why we use data plane each device? This plane handle a traffic whenever a routed packet receive or device send actual traffic. If you want to upload, if you want to download, if you want to communicate, so this one will be handled. Why we use management plane? This plane will provide management option for device. Sometimes it's a GUI, graphical user interface. Sometimes CLI. CLI means command line. If you're having any doubt about GUI or CLI, if we can get access router in GUI or CLI, if we can get access switch, if we can get firewall, load balancer, it's only depends on your vendors. If vendor will provide a GUI or CLI option, so you can access. Now service plane. This one is very important. Everyone use in production network, enterprise network, data centers, service provider, and ISP sites. Why we use service plane? This plane handle a device information. Device information means if you're having a CPU related any issue, any information, if your CPU utilization high, low, overutilize, clear. If you are getting some bugs, so this will be handled service plane. If you are having any interface issue, if you are having any security issues, some bugs, some any attacks, so we can get informed immediately. If you have any hardware, any software issue, so we can get in service plane. For example, if you know about SNMP, why we use SNMP? To collect the informations. Yes or no? Each and every device. So basically, every device will maintain this place. For example, it's a small diagram. If you're having a router number 1, if you're having a router number 2, if you're having a router number 3, if you're having a router number 4, each routers connected with this type, for example, each router. Clear? Now, this router connected with switch and switch connected with some of LAN users. Okay. Now, this router also connected with a switch. This switch also connected with some of LAN users. This side we are connected with a switch 1 or switch 2. Switch 1 connected with a server. This side also server. And this side are connected with some access points, some other devices, management users. This one is my management users. Now, this router connected with my ISP side. So this one is a small diagram. For example, one more thing. This one is my X network, or you can say this one is my this one side. We are using 10.xx network, clear? And this side we are using 11.11 network. Okay, this side we are using 12 network, clear? And this one side we are using 13 network. Okay. Basically, in between routers, we are also using some networks. So in traditional routing, we already done how to assign IP designing concept we already done. If you already complete CCNA, CCNP part, so you already have some basic scenarios, how to design IP address, clear, in enterprise network. So in between router 1 or router 2, we are using 10.1.12.0 network. In between R1 or R3, 10.1.13.0, 3 or 4, 10.1.34.0, R2 or R4, 10.1.24.0. In between router or ISP, we are using 12.0.0.0 slash value 30, 12.1, and this side 12.2 ISP side. Now, if I'm saying this LAN users want to access this network, how to access? We need to perform routing. For example, if I'm performing EIGRP, if I'm performing OSPF, if BGP, so this protocols will use some metric concept to calculate best path. EIGRP, OSPF metric is a different. BGP having some path attributes. Local AS, next hop, self-advertise, AS paths, a multiple attributes you can elect. But for example, this one is my 10 GB link. This one is 1 GB. This one is 1 GB. And this one is a 10 GB. So in this case, router 1 trying to get a best path to reach this network. Which one is my best path? R1 to R3, R3 to R4, 10 GB, na? So we are getting this one is my best path. After run dual algorithm, we are getting this one side is my backup path. So basically how to get best or backup after exchange updates. Yes or no? And updates will carry 12 dot, 10 dot, 11 dot, 13 dot networks. Clear? Now, router one say I'm sending some users traffic for this server, no one. After sometimes, basically this one link goes down. So router one elect this backup path to forward your traffic. But if your link goes down, then devices will again calculate, again exchange network information. Clear? So in this case, this router maintains separately control plane, separately data plane, and separately configure a routing. You just need to access router one and then run the command router AIGRP, then AS number, then network command, then neighbor command. You need to run this commands each and every router, and each and every router will exchange updates. Each and every router will forward your traffic, receive your traffic. So control plane, data plane, management plane, each routers will maintain router 1, router 3, router 4. If control planes, some route goes down, then control plane again learn the information again. So that condition, all routers will get a topology changes. So in traditional routing, if you're having a 10 routers, 5 switches, 2 firewalls, or if someone route goes down, then again exchange. If you want to connect multiple sites, you need to configure some information on 10 routers, some information on 5 switches, some information on 2 firewalls. So in traditional routing, we are getting a complicated because each and every device required high-end CPU, high-end bandwidth interfaces, extra memory to store extra information. In this 4 router, if we are receiving only 4 routes, 4 network information, so no issue. But in enterprise network, if we are receiving a 10,000 prefix or 10,000 network information, then this routers must be having extra memory to store information. Now, after traditional routing, we just need to move on SDN concept. In a traditional routing, we are getting some issues because we required high-end devices to perform traditional routing because each device maintain 3 planes: control, data, management, and service. So we just need to move on SDN. Before SDN, we are also getting IWAN technology, but this technology getting some issues. So that is the reason we are not using IWAN technology. After IWAN technology, we introduce SDN. SDN means it's a software defined network solution for enterprise network, for data center network, for service provider network, for ISP network also. Clear? So this solution available. Basically in SDN, we are getting a 3 types of technologies. But before doing technology, must be clear. SDN will provide by a multiple vendors. But we discuss only which one vendor? Webtail. Okay. So this vendor we are using. In 3 types of technology, we are getting a which one? First, second, and third. First is my SD access. Which one? SD access. Then we are getting ACI concept. Then we are getting SD-WAN scenarios. Must be clear, SD access first. I think last time we are getting some design now. So just give me 1 second to verify design is available or not available. Yeah, this one is available. Very good. So I just need to remove traditional routing because right now traditional routing we are not discussing. We discuss software defined network. For example, In this design, we just need to implement SDN concept. So how to implement? First solution is SD access. SD access only work on LAN environment, a local area networks. So in local area networks, we can configure distribution switches. We can manage by access switches. We can manage by some end devices, servers. So in SD access concept, we are using this person. So will be handled by this one part. Which one person? SD access. This one also integrated, clear, with this one person. If you're having some basic knowledge about ICE, so we can use, okay? Now, second solution, we just need to follow ACI. ACI will implement in data centers. In data centers, we are using some other concept, but ACI will use some epic scenario. This one is type of controller we are using in data center. Now, one more type of technology available. Which one? Which one is third type of technology? This technology called SD-WAN. Why we use SD-WAN? Basically, SD-WAN will handle your WAN network. WAN network means we can manage your WAN devices. This device also we can manage. This one, this one. So this part managed by SD-WAN. So we discuss only SD-WAN concept. In SD-WAN, we are calling a software defined wide area network. In SD-WAN, we are using some controllers. We are using some managed devices. Clear? We are using some analytics device also. So this type of devices we are using. Now, one by one, basically why we use these controllers? This controller will help to maintain your control plane separately, data plane separately, management plane separately, service plane separately. So in controllers, we can get only some types of controller we are using in real time. For example, first controller we are using vManage. It's a short form of VM. Its name vManager. This one is only for management place purpose. Only management plane purpose. This controller will handle. Now, second controller is a vSmart. So why we use vSmart? If you are getting any updates, any routing, any policy, any path manipulation, any filtering, any load balancing scenario, so we can perform on vSmart. So vSmart will handle your control plane. This controller will handle control plane separately. Now, next device. Next device is vBond. Basically, this one controller is new. It's called a vBond. This one will maintain authentication concept, or you can say orchestration plane, OP. Clear? Now, in managed devices, we are using same routers, but this routers we are calling iOS X is supported. Must be having this one iOS. Then you are calling a managed devices because this type of iOS support SD-WAN concept. Clear? SD-WAN. So this routers will maintain DP. DP means your data plane. Clear? Which one? Data plane. Analytics we are using for monitoring purpose. Separately, you can analyze your networks. Separately, analyze your data traffic flow. Separately, analyze your device information also. Now, one more thing we need to discuss those controllers we can deploy physically or virtually or cloud platform. Okay, but if you want to deploy a physically, so must be have UCS type of server. If you want to deploy virtually, so you can use VMware XIS. If you want to deploy a cloud platform, so support AWS, Azure, Cisco Cloud, or you can attach with your private cloud as well. Clear? But must be clear one thing for controller, only for controller. If you deploy, if you're onboarding your controllers, must be having a license. This license we can get from Cisco. Okay, Cisco will provide this license, and this license will help to onboarding your controllers or manage devices as well. Okay, this license concept you can perform by enterprise, a CA server concept also. CA server means certificate authority server. So this server will install by Windows, a server operating system. If you have it, then we can perform. Now, one more thing. Managed devices, we can use physically, we can use virtually, or virtually you can say cloud-based as well. But physically, we are using some ASR series, some ISR series, some CSR series also. Clear? Now, some VH we are using. VH means it's a Viptela Vantage devices. Clear? This Viptela Vantage devices we are using, but this Vantage devices EIGRP not support. Clear? So he can support OSPF, BGP, MPLS, static routing, default routing, VRF, tunnel, and multiple lots of things. But EIGRP not supported. Now one more thing. This Vantage devices depends on requirement deploy. If we are having number of users or devices are limited, so we are getting a different types of Vantage devices. Some Vantage devices with Wi-Fi connection, some Vantage devices we are getting a extra CPUs. Clear? Some Vantage devices we are getting extra ports with 10 GB, 20 GB. Clear? With extra ports 2, 4, 6, 8. Some Vantage devices PoE concept supported. Clear? Now, some Vantage devices power supply, extra power supply for redundant RPS, redundant power supply concept. Now, this controllers, if you deploy, so this controller will maintain your control plane, data plane, management plane, and service plane. So this controller also having some CPU, RAM, storage, some interfaces information. Clear? Some other information also available. Clear? So CPU, RAM, storage, interfaces depends on your requirement. If you are having a small network, so you can use a limited, but if you are doing a lab, so device must be having, your laptop or server must be having up to 128 GB RAM with 8 core processor or 16 core processor, up to 128 GB RAM, and with SSD, minimum SSD required 1 terabyte in your laptop, in your server. So in this case, how to perform lab, how to discuss this SD-WAN scenarios. So basically we are having some servers. In our servers, we are using 256 GB RAM, 180 core processor, and storage is 2 terabyte SSD and normal hard drive 500 GB. So we can easily perform, but this server will get a time duration. If you want to access this server, so time duration. In this server, we can perform complete SD-WAN labs. We discuss 3 labs, lab 1, lab 2, and lab number 3. Lab 1, we discuss onboarding, license concept, connectivity with under relay protocol. Which one? Under relay protocol. If you are having any confusion with under relay, so we can discuss, no worry. Okay, in lab 2, we license managed devices. Managed device, license, connectivity, clear? And then we discuss one more thing, route exchange process. We discuss 2 types of route, V route or VRF route. We discuss. And we discuss in this lab 2 VPN concept. VPN number 1, VPN 0 and VPN number 512. Okay, in lab 3, we discuss OMP concept, T-lock concept, tunneling concept, clear? Templates, we discuss. Okay, after done lab 1, lab 2, lab 3, we start advanced part. In advanced part, we discuss, you can say we discuss policy, filtering, path manipulation, clear? Load balancing, some application aware routing, deep packet inspection, DIA, direct internet access. And then we are also discuss one more thing. We discuss net concept, T-lock extension. Then we discuss a very important cluster concept, then how to back up, how to upgrade or restore scenarios. Basically only 3 labs. In lab 1, lab 2, lab 3, we discuss complete SD-WAN. Then after completed SD-WAN, you just need to download lab 4 and do your self practice. This one lab is different with multiple vManager, multiple vSmart, clear? With multiple managed devices, multiple sites, clear? Redundancy, load balancing, path manipulation, you just need to perform. So this one is your complete SD-WAN scenarios, why we use and which one scenarios we are using SD-WAN. We can discuss SD access, we can discuss ACI, but it's a different type of technology. We just need to follow only SD-WAN for WAN. If you are using a SD-WAN, so no need to use high-end routers. Basically, control plane, data plane separately maintained by a controllers. So if you are having a normal router, with CPU, 2 core, with a storage 1 GB, with 10 GB links, so no worry. You just need to connect with your vManager, connect with your vSmart, and attach with your vBond. Okay, if this branch connected with ISP, so first thing, this branch must be know this person. Basically, this person authenticate your this managed devices. Clear? After authentication, this vBond will share 2-person information, vManager, vSmart, and then this managed device will maintain separate sessions. And now, if this Vanish device sharing thousands network informations, for example, 1,000 routes. So no worry. This Vanish device first send vSmart, and this vSmart will carry and will handle. No need to use this CPU. And after handling, this vSmart will share. Okay? In a specific VPN, specific VRF, specific tunnel with a secure connection. Some IPsec concept. Clear? So it's very important. Now, if you want to manage multiple branches, so no worry. Just go to vManager. This vManager will provide this Vanish device, single dashboard. Clear? Single dashboard. In this dashboard, you can get access GUI, you can get access CLI. If you want to manage, if you want to troubleshoot, you just need to connect your branch router with ISP and provide only vBond information. No any other information required. No routing, no switching, no path manipulation, no best path selection. Only connect your vBond. Then automatically we can use. Okay. Now, one more thing you just need to follow. Basically, we can also use ZTP concept. ZTP concept means a zero touch provisioning. This one feature we are also using. We are also using PNP concept. Okay. So both concept we can also discuss, ZTP or PNP. Okay. Take your time, go through this video. We can meet again next session and we discuss some advanced part. Okay. Bye bye. Good nights, everyone. Good Simran.